Hey guys, welcome to this example video. This is substitution for definite integrals. So in this video, I am going to go through these 4 examples. If you're looking for more of a breakdown of how substitution actually works with definite integrals, I have an entire lesson where I break all of that down using 2 methods. In example videos, I just show you the 4 examples and then I just show you the steps through them. So I kind of assume you already kind of understand the basic idea. So if there's a specific one that you want to see, you could of course just fast forward to it. And if not, you can use this as a way to like quiz yourself, or you can just hang tight. Okay, so let's get started. So starting with the first example. So I'm going to show you the 2 different methods that I talked about in that video, my lesson video. So in the first way that you can approach these, so you can actually just go ahead and evaluate the indefinite integral. So I get rid of the numbers that are on the integral sign and I just evaluate this. So if I wanted to do this using way 1, so this one's at least nice and straightforward. So my u is 1 plus the square root of x, and my du is going to be 1 over 2 times the square root of x dx. So that is a nice straightforward substitution. And so then I end up getting, so let's see, I'll really rewrite this as u to the negative second du. And so then if I go through and I evaluate this, this will be negative u to the negative 1 plus c. Now, this is what you do with way 1. Then what you do is you take really just this part here, so you ignore the plus c, and now you plug in your limits of integration. So in this case, now I'm going to just have negative u to the negative, oh, sorry, I didn't totally finish that. So I still have to plug in my x. So my x is negative 1 plus the square root of x to the negative 1 plus c. Okay, now we're good to go. Okay, so taking this part, so now basically I'm just going to plug in my limits of integration. So this is going to be negative 1 over 1 plus the square root of x, and now I need to plug in 1 to 4. So if you do all of that, so you're going to get negative 1 over, this will be 1 plus the square root of 4, plus 1 over 1 plus the square root of 1. So this comes out to then negative 1/3 plus 1/2. So my answer in this case, I'll just write it up here. My answer in this case came out to 1 over 6. 1 over 6. Okay, so that's the first way that you could do this. Now I'll show you the second way, so let me clear this all off. So now we can try way 2 here. And so it's still the same startup. So I'm still going to use my same u, so it's still this 1. Yeah, I cannot write today. My pen is not working. 1 plus the square root of x. My du is 1 over 2 times the square root of x dx. But the plot twist with this is that you also change your limits of integration so that you don't have to remember to plug them back in at the end. So starting with this one, so if x equals 1, now I'm going to plug this into what I set for my u right here. So this will be u equals 1 plus the square root of 1, so this equals 2. Then I move on to the other one. So if x equals 4, once again, I'm going to plug this right into what I set up for my u substitution. So this will be u equals 1 plus the square root of 4, so this will equal 3. So now I can make those substitutions. So the way that this is going to look then, my 1 will become that 2, and my 4 will become that 3. Okay, so now I've got all that set up and I can also replace all my other u's, so this is still u to the negative second du. So as you can see, this is a very, very similar outcome. It's just you have these different numbers here. So I'm actually going to be just doing way 2 for the rest of this video. Although if people really want to see more of way 1, you can always leave me a comment and I might be able to make some more videos. So just kind of curious what your preference is. Okay, so I'm going to go ahead and finish this now. So this becomes negative u to the negative 1. So now I don't have to go back to replacing these guys over here. I've already changed my limits of integration. So let's see, do I get the same thing? So this becomes negative 1/3 plus 1/2, which still equals a 1/6. So we're good to go. So the idea behind this is that you should still get the same numerical answer and you will at least see kind of what my integral should have come out to be. So there's a lot of overlap between the 2 ways, so this is why I'm not going to repeat all of them. Okay, so just using way 2 going forward now. So for this one, Your u in this case is going to be cosine of x. Therefore, your du is negative sine x dx. Therefore, my negative du will be sine of x dx. Now, this is one way that you can kind of handle this. I personally like to make all my manipulations to the du, but I've talked about in other videos, you could also just kind of manipulate with the dx. So there's more than one way to kind of do this, and it'll all come out the same. Okay, so now I also want to change my limits of integration. So when x equals 0, that means that if I plug that into this, then my u will equal 1. And if x equals pi over 3, then my u will equal the cosine of pi over 3. So this is 1/2. Okay, so now I can go ahead and change my limits of integration. So the 0 becomes a 1, and the pi over 3 becomes a 1/2. And then the rest of this will be really u to the negative second times negative du. So I have a few things to mix around here. Now, just a heads up. Notice with how this is written, my limits of integration have kind of flip-flopped. So normally we see the larger number on top, but sometimes when you do this substitution, you're going to have them flip-flop. So you can plow ahead with the problem just like this. But sometimes this really bothers people, so some people really want the largest number on top. So if you want that to happen, you could just flip the limits of integration, and then you would just have to change the sign of the integral. So I don't want to do too much at once here. So first let me just rewrite this so that I bring this negative out in front. So I'm going to bring this negative out here. So that's all I've done. And then I'm going to go ahead and flip my limits of integration here. So now this goes from being negative to positive again, because the negative and a negative will cancel themselves out. Okay. Now we're back in business. This looks very similar to the last problem. So this becomes negative u to the negative first. And then I just have to plug in these numbers here. So this will become negative 1 plus 2. So all of this will ultimately equal 1. So just remember, when you take 1/2 to the negative first, that really just gives you the reciprocal of that fraction. So that will just leave you with 2. Okay. Moving on to C. So in this case, my u is going to be 1 plus 3x. My du will be 3 dx. Therefore, 1/3 du will be dx. So that just helps me. Now, notice that when I set this up, so this is something I've discussed at length in some of my substitution with indefinite integral videos. So you can see that this is not going to be covered by the du, so we're just going to have to rewrite x now in terms of u. So using this line here, I effectively am just going to solve for x. So what I get then is x is equal to, so if I solve for this, this will be 1/3 u minus 1/3. So you first subtract the 1, then divide everything by 3, so you get this. So this is going to allow me to replace this part of the problem here. So if this is just like totally something that does not seem familiar to you, check out some of my videos and examples for indefinite integrals. I talk about this trick quite a bit there, so I think that's a really common trick. Okay, so I still haven't changed my limits of integration, so I've still got to do that. So now, let's start with this one, so starting with 0. So when x is 0, then my u will be 1 plus 3 times 0, so this is 1. And then when my x is 1, my u will be 1 plus 3 times 1, so this equals 4. Whew, and now I can finally actually do this, right? So now I can flip my limits of integration, so this goes from 1 to 4 now. And then in this problem, so it looks like I'm going to have my x will now be 1/3 u minus 1/3 times the square root of u, all of this times 1/3 du. So remember, I said my dx is equal to 1/3 du. So here's how I've made that replacement. So now this is all kind of a bit of a mess. So notice I can factor out this 1/3 out in front. I'm also going to factor out 1/3 from in here. So if I factor out 1/3 twice, this becomes 1/3 times 1/3, so this is 1/9. Okay, so this will leave me with u minus 1 times u to the 1/2 du. Okay, so that's just factoring out some numbers. Now I need to distribute all of this to make this something that I can integrate. So this becomes u to the 3/2 minus u to the 1/2. And now I can finally integrate. It's about time. So let's see, I've got 1/9 times, let's see, this is 1/9 times 2/5 u to the 5/2 minus 2/3 u to the 3/2, and now all of this has to be evaluated from 1 to 4. Okay, and now, let's see, this is going to become, oh, I'm running out of space here. Let me, let's see, I'm going to erase part of this so I can get some more room. So hopefully you've written this all down. Okay, so I just took where we were at and I just moved it all over, so now we can keep plowing ahead with this. So now I just need to plug my numbers in, really. So this will be 1/9, so 1/9 times 2/5 times 4 to the 5/2 minus 2/3 times 4 to the 3/2, and then this minus 2/5 times 1 to the 5/2 minus 2/3 times 1 to the 3/2. Okay, and so now when you break this all down, so I'll just kind of do this now in pieces. So starting with this piece here, so depending on how far you actually evaluate this, so this becomes 1/9 times, let's see, 1/9 times, so this first part, this comes out to 64/5 minus 16/3. Okay, and then this second part, which I'll write in pink, so this comes out to minus 2/5 plus 2/3. So then if you finish computing all that, so I'll just tell you the decimal. I think I've taken you to kind of far enough. So this will come out to 0.859 as a decimal, or you can continue working out those fractions to its equivalent. Okay, so now we have one more left. So for this one, so my u is going to be tangent of x, and my du will be secant squared x dx, so that's nice and straightforward. Then if my x is pi/6, the tangent of pi/6 equals the square root of 3/3. And then if x equals pi/3, then the tangent of pi/3 equals just the square root of 3. And so now I can go ahead and use method 2. So this becomes the square root of 3/3, and this is the square root of 3. This is 1 plus e to the u du. So now I can go ahead and evaluate that. So this will be u plus e to the u, and now I need to evaluate this from the square root of 3 and square root of 3/3. Okay, so like that. So I can plug everything in. So this will become the square root of 3 plus e to the square root of 3 minus the square root of 3/3 minus e to the square root of 3/3. So either you've written all that, maybe you work through all your fractions, or if you're just looking for the decimal equivalent is 5.026. So that would finish out that one. Okay, and so that covers it for my example videos. So like I said, if you are looking for a longer explanation, you want to see how the two methods work a little bit more, I have another video where I do go through all that. So feel free to check that out if you feel like you need a little bit more on this topic, or if there's something else that you're looking for, feel free to leave me a comment and I might be able to make you a video on it. Thanks for watching.